Threads are of great importance in the modern world, beginning around 400 BC with the first screw threads being used to compress grapes and olives for juice and oil. Threads have seen much development from their initial conception until today. The design of threads for fasteners and power transfer relies on several important measurements and metrics. One of the most important of these metrics is the pitch diameter. Pitch diameter is an important metric because it dictates how well threaded parts will mate together. The pitch diameter is the diameter of an imagined cylinder passing through the teeth of a thread such that the width of the teeth at its intersection is half of the thread pitch. If two parts have mismatched pitch diameters, either the parts will be too loose relative to one another, or the parts will not have enough space and bind up or seize. In applications requiring the precision cutting of threads, the three-wire method offers an accurate way of measuring the pitch diameter of threads. The three-wire method is performed by placing the three wires on either side of the threaded part as shown. A micrometer reading is taken of the over wire measurement, which can be used to calculate the pitch diameter. This measurement is equal to the pitch diameter plus the wire diameter plus twice the small space between the pitch diameter and the center of the wires. The size of this small space can be found by subtracting the distance between the trough of the teeth and the center of the wire and the distance from the trough to the pitch diameter. This first distance can be found using the shown trigonometry to be half the wire diameter times the cosecant of half the thread angle. The second measurement can be found using the definition of the pitch diameter and the trig shown on screen, equaling the thread pitch divided by 4 times the cotangent of half the thread angle. Putting these measurements into the previous formula, simplifying and rearranging, we have the formula to find the pitch diameter from the measurement over the wires. For U.S. standard and metric threading, which both use 60-degree threads, this formula simplifies to the following. The three-wire method can be extremely accurate, but relies on several assumptions. The first assumption is that the wire diameter lies on the pitch line of the threads. While achievable in many cases, sometimes machinists lack the wire of the necessary diameter to make this true. In such cases, other wire diameters may be used. The wire diameter that will land on the pitch line of the threads can be found by the formula shown on screen. Additionally, the three-wire method assumes that there is no impact from the lead angle of the thread. This assumption holds for screws with lead angles up to 5 degrees. As stated earlier, the three-wire method offers an accurate way of measuring the pitch diameter of threads for precision applications. Precision threads offer many benefits. First, precise threads minimize the amount of misalignment that may present in an assembly. Precise threads also experience less wear. Furthermore, for power screws, precisely cut threads will transfer power more efficiently.